Hello there, college algebra students. This is Mr. Kashi speaking. This video is going to go through the first 4 slides of the 2-1 power and radical functions lesson. If you get stuck, you can refer to page 86 in your textbook. I might be going awful fast during some of the examples, so feel free to pause the video whenever you need to. But today's lesson is just taking a look at power functions and radical functions. Right now, these first examples, we're just going to be analyzing what we call monomial functions. Okay, so just a couple of definitions here highlighted for you up there. A power function is any function of the form a times x to the n, and a monomial function is any function that can be written as a or a times x to the n. So here are a couple of examples, the graphs and all the descriptions. So if you had a even function on the left with a parabola, all of the different characteristics of them. You have domain and range listed here, things that we've talked about before, x and y intercepts. You have your minimum, and when, well, the thing that we're going to be talking about mostly in this is when it's decreasing and when it's increasing, which is rather important for a pre-calculus class. So then obviously if the parabola has an a that is negative, the graph is shown here at the right, and most of the characteristics are the same, but you can see how some of them have changed now that it is flipped over the x-axis. Next thing would be monomial function. If this was a cubed, x cubed, and an odd positive, it would be on the left, all the characteristics of it here with the domain and range, and the symmetry and the extrema, and basically, once again, the one thing that we're going to be focusing on quite a bit today is when it's increasing and when it's decreasing. So these are some characteristics you want to obviously have on hand, so we can reference for later examples. But here's an example that I'd like to go through. Graphing a monomial is going to be a way that we can analyze it, and really the one simple thing that we need to realize is that we're just plugging these values in, and some of them might run off of our graph, which is fine. All right, that's not the important part. We want to get these shapes down, and we want to make sure that we understand why the shape of the graph is what it is. So I'm just going to be filling in this table and plotting some points, putting in the graph, and then talking about the characteristics below. So we have 1/2 plugged in, -3 plugged in, cubed, and we're going to get that to be 40.5. And if we plug in -2, -2 to the 4th, that would actually be 16, and half of that would be 8. And we have 1/2, -1 to the 4th. Well, 1 to anything, or -1 to even is going to be a +1. And then we're just going to get 0.5. If we plug in 0, we're going to get 0 as well. Plug in 1, and this x to the 4th is just as symmetrical as a parabola would be, and so we're going to be getting those same values that we had up above. Okay, so then we plot those over here. So if, that -3, 40.5 is obviously way off of our graph, but if we have -2, 8 is right there, -1.5, 0, 0, up, and we have 1.5 is our point, and then we have 2, 8. So we're just plugging in, using these as our points that we just graphed on our coordinate plane over here. And then I would try to take my graph a little bit wider to make sure that we are not crossing these points here of 1, 1 and -1, 1. Those should be showing, so we can determine this between so that it's not a parabola. This is 1/2 x to the 4th. Okay, so here we want to go through some of these characteristics. Okay, First is the increasing, and we're going to be writing these in interval notation. Okay, so increasing is just when the graph is going up, and when and then obviously the opposite of that would be when it's going down. So increasing would be from 0 to infinity, and we would not include 0 in this case because as 0 it's really not going up or going down. That would be our minimum of that graph. And then decreasing would be going from negative infinity up to 0. Whenever you're writing in interval notation, you want to have it in numerical form or numerical order, going from left to right. Okay, so hopefully that's pretty self-explanatory with when we're going up and when we're going down with the graphs. Our intercept is what we're talking about is our y-intercept here, even though it's the same as our x, and that would be a 0. Now we're talking about behavior. End behavior is going to be important, just as important as the increasing and decreasing. And this has to kind of go back with our discussion on even and odd functions. So end behavior, when we say the limit as x goes to negative infinity. So basically, as we're going down, which way is our graph pointing? And hopefully you can see here, when we're going towards negative infinity, our graph is going up and it's pointing towards positive infinity. And then on the other side of that, if we have a limit as x goes to a positive infinity, basically just meaning as x increases, what's happening. And so here, as you can see, gotta dip it in the ink. Here, as you can see, as x is increasing, our graph is pointing up to positive infinity. So that would be positive infinity for that blank as well. And then lastly is our domain and range. Hopefully you can see it's how close it is to a parabola. Our domain has no restrictions. You can go all the way down to negative infinity, all the way up to positive infinity. Okay, so that's not as exciting. But our range, we do have a minimum value. So our minimum value would be here. That's our origin of 0, 0. That's our minimum. And so our range would start there, and obviously with our end behavior both going in the positive infinity direction, our range would be going from 0 up to positive infinity. So go ahead and pause if you need to keep taking notes, or rewind if you need to retake some notes, but I will be going on to the next slide here. We have one more. If you would prefer to pause this and try to do this one on your own, that would probably be the best process of going about this. But I am going to go through this function f of x equals negative x to the 7th. This gets a little tricky just because of that negative. When we go to plug things in, that negative has to stay on the outside, but I'm also plugging in negative 3 in for x, and that gets a little out of hand here. We get 2,187, so we will not be plotting that point either. And the next one doesn't get a whole lot better. We're plugging in negative 2, and because our exponent is so big, that's going up to 128. So once again, not the best for graphing in this case. Because we have an odd exponent, once we take a negative to the 7th power, it's still going to be negative. And so then we multiply by the negative out front. That's how we're getting these positive answers here. So here we have plugging in negative 1, and we get a value of 1. And then we're plugging in 0. And then going down to the positives, we're actually going to be getting y values that are negative. And I'm plugging in a 2 to the 7th. They're still going to be the same values as up above, like the symmetrical numbers that we've been seeing in our parabolas and just our last example too, but in this case they're going to be negative. So really we can't be plotting a whole lot. We can only be plotting these middle 3 ordered pairs, and so really it's a base, but it's important to make sure that we're going in the correct direction. So obviously we're in the origin here. We have negative 1, 1, that's a point there, and we have 1, negative 1. But then you can see how fast it increases from 1 to 2, and then obviously from 2 to 3, and on the other side negative 2 to negative 3. So these graphs are going to be going up very, very drastically from those points. I like to kind of draw those in first. Okay, and then we want to make sure that we come over here and connect those just like that. So obviously x to the 7th with an exponent like that, we're going to have some y values that are going to be increasing or decreasing quite rapidly. If you take a look at this, the decreasing going from left to right, okay, we're going to always be decreasing with this graph quite rapidly at most of the time. Right when we get in between negative 1 and 1, it's not decreasing as fast, but it is still going in the negative direction. Our y-intercept is also 0. This is an odd function, so our end behavior is going to look a little different. So as x goes to negative infinity, so I always like to talk about this. So it's as x is going to negative infinity, that's on this side. Okay, so as x decreases, what's happening to our graph, and hopefully you can see that it's going up to positive infinity. And then on the other side of the y-axis, as x goes to positive infinity, hopefully you can see as we're going right here that the graph is pointing down, and that would mean that our end behavior is going down to negative infinity. And then last thing that we're going to talk about for this example is the domain and range. The domain, hopefully you can see, it's kind of hard to see that it would be going on forever to the left and to the right because it leaves our graph on the top and the bottom so quickly. But here the domain would go all the way down to negative infinity and up to positive infinity, and the range would be doing the same thing, going from all the way down to negative infinity to positive infinity. So those are some of the characteristics of negative x to the 7th. I'll have at least one, maybe two more videos with this same lesson, moving on to negative exponents and some radical functions as well.